So the types of training. So that's the energy systems now. Let's have a look at the types of training. So there are 4 types of aerobic training. Now you need to know each one. So there are 4 types of aerobic training that we're looking at, and 1 type of anaerobic training that we are looking at. Definitely note this down. It can be always a bit hard to remember them as well. So with the aerobic training, so firstly, we've got continuous aerobic. So continuous aerobic is when you've got no rest. It is sustained effort, and it generally works to improve aerobic performance. Next, we've got fartlek. So fartlek is when you vary in speed and terrain. So energy systems combine here because you are mixing, like, you're going at varying speed. So, like super fast sprinting and then slow running. So, or jogging. So the energy system combined with the aerobic is prominent because it is like still continuous training, and this can be very specific to the sport. So if you've got something like, let's say, soccer, you're focusing on endurance but also speed, like when you do need that speed to run very fast. Then we've got aerobic intervals, so continuous, no rest, sustained effort. Fartlek, we are changing up the speed and train. Aerobic interval is when we've got rest and recovery alternately. So what that means is, you do your exercise, or whatever the training is, you rest and then continue. But these intervals are short. However, you are going at your 100% VO2 max, which means that it's tapping more so into the anaerobic system. VO2 max refers to the maximum amount of oxygen a person's body can absorb during exercise. So if you're going at 100% VO2, that means it is high intensity. Hence, aerobic interval is alternating sessions of rest and recovery. Finally, we've got circuit training. So as the name suggests, you're moving from one station to another, and it improves both aerobic and anaerobic capacity, so flexibility and coordination. Okay, the anaerobic training. So anaerobic training includes both the alactic and lactic acid system. So with this, what we've got happening is basically you are both anaerobic systems, alactic and lactic acid, so you're sort of varying between that sort of time. So like, for example, firstly, it's for athletes that are in non-endurance sports. You don't need endurance, you need that explosiveness. High intensity and short duration. So you're going like 80 to 85% of maximum heart rate. That's quite a lot. The work-rest ratio is 1:3. So if you are working for 5 minutes, you've got 15 minutes rest. So that rest is obviously a lot more because of the energy that it's using. This is why it's for non-endurance sport. So you're going really hard and fast, and then you stop for like 15 minutes after going hard and fast for 5 minutes. Rest can include being stationary, just sort of sitting down, or it can also include like easier intensity exercises or stretching. Intervals performed in sets of repetitions, so they're designed to overload the anaerobic system. Remember, with all of these exercises and training types, the purpose is to become better, to make your anaerobic or aerobic energy system better and enhance its performance. Hence why they are designed to overload in order to improve, and that's like that's something that you talk about in the principles of training when we talk about how progressively overloading the system is important. Lactic acid intervals include 10 seconds, and lactic acid intervals can include up to 2 minutes to prove body's tolerance to lactic acid in the bloodstream. So let's now have a look at the physiological adaptations. So how is the body, adapting to all these exercises? Starting off with resting heart rate. So resting heart rate refers to the number of contractions that the heart makes per minute at rest. So that's when you're not doing anything, when you're sitting down, you're relaxing, that's your resting heart rate. So in an untrained person, the resting heart rate is generally around 70 beats per minute, in comparison to a trained individual whose resting heart rate would be like 40 to 50 beats per minute because they're more fit. The stroke volume refers to the volume of blood which is pumped out of the left ventricle per minute, and this is because the training increases the strength of the heart muscles. The more you train, the more you're overloading, you're increasing the strength of your heart muscles, and therefore that increases the stroke volume. Finally, cardiac output. So cardiac output is your heart rate multiplied by your stroke volume. So that gives us the total volume of blood which is pumped by the heart per minute. So with this, and you can see how that would mathematically work. So heart rate, it beats per minute, and stroke volume is volume of blood that's pumped out per beat. So we go per beat times per minute to give us the volume of blood which is pumped by the heart per minute. And at submaximal exercise levels, there is little difference between trained and untrained athletes. So it's, when a trained athlete who is not like submaximals are not very trained, like, they may exercise regularly, for example. However, at a maximal level, a trained athlete does have higher cardiac output than an untrained athlete. And again, that would be because they're improving their stroke volume, their resting heart rate is lower. So that's that. Okay, so now let's have a look at hemoglobin levels. So hemoglobin is the protein in the blood that binds to oxygen and delivers oxygen around the body. So hemoglobin level does increase with training, especially if you're doing altitude training. So altitude training, it will increase obviously because you're at a higher altitude than sea level, and because of that, you need to absorb more oxygen because oxygen is less in higher altitudes. So that would mean that you're trying to get more oxygen delivered, and athletes can maintain a higher average speed as a result of that. The oxygen uptake refers to the amount of oxygen in the body. The amount of oxygen refers to the oxygen the body absorbs in 1 minute. So generally, aerobic training increases your oxygen uptake, which means that there's more available for ATP production during the aerobic training. And oxygen uptake is also called VO2 max. So we looked at VO2 max when we talked earlier about aerobic interval, and how, because it predominantly challenges and overloads the aerobic system, it increases the VO2 max. We've got lung capacity. The size of your lungs does not change. Your lung capacity does not change with training. There's no significant change with training. There may be a little, but it's no significant change. Finally, muscle hypertrophy. So muscle hypertrophy is when there is a growth in your muscle cells and mass, but there's no change in length. So the length of your muscle never changes. Obviously, until it's, the actual length of it doesn't change, but there is growth in the muscle cells and the mass of the muscle, which makes obviously look bigger. Now, looking at the effect on fast and slow twitch fibers. So this refers to the amount. So fast and slow twitch fibers. Basically, we've got both in the body. That's very important to sort of remember first. You've got both fast and slow twitch fibers. Fast twitch fibers are those that are generally attributed to like explosive movements. So explosive movements like very high energy, in comparison to slow twitch fibers that are more about endurance. So the amount of each type of fiber depends on the function of the muscles. That's very important too. So for example, a part of the calf muscle has more slow twitch fibers because we need that endurance to, for example, stand up and walk around all day, right? So that's important. There's a muscle in the calf that has that like more amount of slow twitch muscle fibers in comparison to your biceps that would have probably more that have more fast twitch muscle fibers, because you need that, for example, to push things away, to like move things around, to lift heavy things. So you've got more fast twitch muscle fibers in your biceps. So long distance runners may recruit more slow twitch muscle fibers, and sprinters can recruit more fast twitch muscle fibers. That does change. So that does change with training as well. So the way we classify them are, first we've got type 1. So type 1 are the slow twitch muscle fibers. So they're aerobic, they're red, they have large number of capillaries and lots of oxygen delivery. So and you can obviously see why that would be, because it's about endurance. Oxygen needs to be delivered so that the body can then so that the muscle, the cells can produce ATP. Type 2A is when we've got fast and slow muscles. So they're anaerobic, white, they have some capillaries, more ATP and PC as well. Finally, we've got type 2B. So those are fast. So type 2A was fast and slow, so we did have that mixture. Well, type 2B is when you've got fast, anaerobic, white muscle fibers, fewer capillaries, very few capillaries, but more ATP and PC production.